Good morning, students. I am Manikant Mishra, Modern English School, New Area. Hope that you all are fine by the grace of God. Today, again, I am going to start atoms and molecules from the beginning. So, we all are aware about matter, and we also know that atom is a fundamental unit of matter, or atom is the smallest particle of a matter. Since 17th century, the scientists were trying when two or more than two atoms of the same or the different elements combine, is there any quantitative relation? Is there any quantitative relation among them or not? So they made a lot of effort in order to establish a relation, in order to establish a quantitative relation between the atoms or molecules. And finally, they came out with the 5 laws of chemical combination. The very first is law of conservation of mass. This was given by Antonio Lavoisier. According to Antonio Lavoisier, he said the law of conservation of mass is nothing but it establishes a relation between mass of the reactant and mass of the product. So what is a law of conservation of mass according to Antonio Lavoisier? During any physical change or chemical reaction, mass remains constant. During any physical change or chemical reaction, mass remains constant. And this also can be stated that neither matter can be created nor it can be destroyed. So that's why matter is indestructibility in nature. Matter is indestructibility in nature. It means neither matter can create nor it can be destroyed. So this can also be simplified during chemical reaction. During chemical change, mass of the reactant is equal to the total mass of the reactant is equal to the total mass of the product. During any chemical change or chemical reaction, total mass of the reactant is equal to the total mass of the product. What is the reactant? A substance which takes part in a chemical reaction is called reactant. Substance which takes part in a chemical reaction is called reactant, and the substance which formed during the chemical reaction is called product. Substance which formed during the chemical reaction is called product. Let us apply these law of conservation of mass by solving the numerical. Now what is what weight of sodium chloride is decomposed by 4.9 gram of sulfuric acid if 6 gram NaHSO4 sodium hydrogen sulfate and 1.825 gram of HCl are produced in the same reaction. Now how to solve it? First of all, you write the chemical equation. So NaCl plus H2SO4 gives NaHSO4 gives NaHSO4 plus HCl. Now once again, what weight of NaCl is decomposed by 4.9 gram of H2SO4. So here it is not given. The mass of NaCl is not given. So let us assume let the mass of NaCl be x gram. Let the mass of NaCl be x gram. Now mass of H2SO4 is given to us 4.9 gram. So write 4.9 gram. 6 gram of NaHSO4. Now sodium hydrogen sulfate. The mass of sodium hydrogen sulfate is given to you 6 gram and 1.825 gram HCl is given. Now, according to law of conservation of mass, according to law of conservation of mass, according to law of conservation of mass, conservation of mass, total mass of reactant equals to total mass of product. Now we have total mass of reactant X plus 4.9 gram. X plus 4.9 gram is the mass of reactant and 6 plus 1.825 gram is the mass of the product. Here NaCl plus H2SO4 is taking part in a chemical reaction. So these two comes under the category of reactant, and during the chemical reaction these two substances are formed, NaHSO4 and HCl. So these two are called product. So now total mass of the reactant is equal to the total mass of the product. We have total mass of the reactant X plus 4.9 and total mass of product we have 6 plus 1.825. Now let us solve it. So X, now send it to that side. Now 7.825 minus, now add to it, add these two, then 6 plus 1, 7.825 and send plus 4.9 to that side, 4.9000. 5 2 now sorry 8. So if I am not wrong, then I think it will come to this way, no? Otherwise, to make sure, 7.825 4.900. So 529,642 2.925 gram. Hence the mass of or hence the weight of NaCl equals to 2.925 gram. Now next question. When 4.2 gram of NaHCO3 is added to a solution of CH3COOH weighing 10 gram, it is observed that 2.2 gram of CO2 is released to the atmosphere. The residue is found to be 12 gram, so that these observations are in agreement with the law of conservation of mass. Now let us solve it. First of all, we have sodium bicarbonate NaHCl CO3 is being added with CH3COOH, so called acetic acid. CH3COOH gives CH3COONA plus H2O plus CO2. Now in the question, this together CH3COONA plus H2O is called a residue. Now the mass of NaHCO3 is given to us 4.2 gram. Acetic acid is 10 gram. Now 2.2 gram of CO2, 2.2 gram of CO2 and 12 gram is residue. NaHCO3 plus CH3COOH gives CH3COONA plus H2O plus CO2. So this CH3COONA plus H2O is in a solution form, that here in the, according to question, the word has been used is a residue and carbon dioxide. As per the information, the 4.2 gram of NaHCO3 combined with 10 gram of acetic acid forms 12 gram of residue, and 2.2 gram of carbon dioxide is released, and that goes to the atmosphere. Now, total mass of the reactant, equals to 4.2 plus 10, that is equal to 14.2 gram. Now total mass of product equals to 12 plus 2.2, which is equal to 4.2. Now total mass of reactant is equal to the 14.2, and total mass of product is also 14.2. It means we can say the total mass of reactant is equal to the total mass of product, which is equal to 14.2 gram. Total mass of reactant is equal to total mass of product, which is equal to 14.2 gram. So this is the only the law of conservation of mass, that total mass of the reactant is equal to the total mass of the product. According to law of conservation of mass, during any physical change or chemical reaction, mass remains constant. So here total mass of the reactant becomes equal to total mass of the product, which is equal to, as per this question, 14.2. Hence this observation justify or supports law of conservation of mass. So please watch this video carefully, and if you have any sort of doubt, any problem, then let me know during your online time. Till then, thank you. Have a nice day.